Welcome, my dear students. So today in this session it is a continuation of yesterday's class. Okay, now flow visualization. So what is this flow visualization? It is nothing but a keen observation of a flowing fluid. So how the fluid actually flows. So what are the patterns it is making while it is flowing. Okay, it will not flow in a uniform way. Sometimes it is turbulent, sometimes it makes a path, sometimes it is like a stream. Okay, so like that. So what are the patterns when it is flowing? So just an observation. So it is called as a flow visualization. Okay, it is important for both physical experiments and also numerical solution. So description of flow patterns. So there are four descriptions. So we'll go through them quickly. So one is streamline, next is path lines, streak lines, and stream tube. Okay, so one by one. So first one is path line and streamline. So path line, what is this path line? See in the figure you can see. So the fluid particle at a t, it is starting. Okay, it is starting and it follows the path like this. And so at some time t, it is like this. Okay, at some time t, at the end it is here. Fine. So the path line is nothing but it is a trace made by a single particle over a period of time. So streamline show the mean direction of a number of particles at the same instant of time. So streamline are the number of lines, okay, directions of number of particles at the same instant of time, whereas the path line is a trace made by a single particle over a period of time. So what is the character of streamline? Streamline cannot cross each other. They will not cross each other. So you can see they are just moving. So if they are moving also they are not crossing each other. Streamlines cannot cross each other. It's its property. Streamline can't be a folding line but a smooth curve. Okay. Streamline cluster density reflects the magnitude of velocity. So dense streamline means larger velocity, while sparse streamline means small velocity. You will get to know. You will get to know in the coming slides. Okay. Now, what are the characteristic of the streamline? So it will not. It can't be a folding line. What is folding line? So whenever the water is flowing like this and obstacle is coming, water not fluid. Okay, whenever a fluid is flowing and an obstacle is coming like this, it will not flow like this and go. It will not flow. Oh, obstacle has came, I have to take shift. It will not go like that. It will be a smooth. Okay, it will directly, it will take turn. You here you can see the smooth curve. Okay, in the mouse I can't draw. The smooth curve it is going like this. Okay, this is the property of the stream line and path line. So next we will see what is streak line. A streak line is the locus of a fluid particle that have passed subsequently through a prescribed point in the flow. So whenever a point has been already prescribed, so to move through the point which is given by the prescribed point which is given by the it is the line shown by the user which he has to move the fluid through that path. Okay, now that line is called as a streak line. So streak line is the locus of a fluid particle. So these are all locus, 1 2 3. It has to move in this direction. Okay, it is injected fluid particle, so this is the line, it has to move like this. So whenever we make the line, it's called as a streak line. A streak line is the locus of a fluid particle that have passed sequentially through a prescribed point in the flow. It is an instantaneous picture of the position of all the particles in the flow that have passed through a given point. It will show the instantaneous picture of position of all the particles in the flow that pass through a given point. So the picture which it gives no, so that is called as a streak line. What is stream tube? Several types of stream lines consist and it will make a boundary. Okay, and that boundary we'll call as a stream tube. So stream tube is an imaginary tube whose boundary consists of a stream lines. So the space in between these four stream lines, so the space bounded by this flow four streamlines are called as what? The stream tube. The volume of the flow rate must be same for all the cross section of the stream tube. So what is the volume flow rate here? It is same as here. Okay. So this is nothing but conservation of mass. You'll get to know in the coming slides. So these were about the visualization of the fluid flow. Now let us see one by one the types of fluid flow. What are the types of the fluid flow? How we can classify it? Okay. So these types of fluid flow are classified in 7 ways, I think so. So first one is steady and unsteady flow, uniform and non-uniform flow. Next, laminar and turbulent flow, compressible, okay, rotational and irrotational flow. Fifth one is compressible flow and incompressible flow, ideal and real flow. So next one is 1, 2 and 3 dimensional flow. So there are actually 7 types of flow. So we will see one by one. So what are it is, its meaning. We'll see the meaning of one by one. Steady and unsteady flow. So what is the steady flow? So steady flow is that type of flow in which the fluid parameters, what are the fluid parameters? Velocity, pressure, density, etc. at a point in a flow field do not change with time. The velocity, pressure, density do not change with time. When it will not change, that type of flow is called as what? Steady flow. Okay. Thus, for steady flow, what we can tell, the fluid particles passing through a fixed point have the same flow parameters. So the fluid particles passing in this type of flow, the fluid particles passing through a fixed point that have same flow parameters, like every particle, fluid particle will be same, will have same velocity, pressure, surface tension, etc. These fluid parameters. Okay, the parameters may be different at a different cross section. The cross section may be different. Okay, at different cross section, the different parameters may be, it is different. Okay, the parameters may be different in different cross section, but at that point of flow the parameters are same. So steady flow is what? It is that type of flow in which the fluid parameters at any point in the flow field do not change with time. If it will not change with the time, the fluid parameters, it is called as a steady flow. Then coming unsteady flow. What is unsteady flow? Before, and mathematically we can see this. Mathematically we can write like this. Very important. You have to keep it in mind. We have to understand what is this. Okay. So this is the term you are already knowing in your mathematics. Okay. What is this term? Partial differentiation. Right. So I'll spell as this as dou. Okay. DOW dou. So now, so dou v by dou t. So what is this dou v by dou t? V is what? Well, V is velocity. Dou v by dou t, that is partial differentiation of time with respect to what? X naught, Y naught and Z naught. Means in the direction of X, Y and Z is equal to 0. Means what? The velocity, okay, with respect to time at X or Y at Z is equal to 0. The velocity is same. Okay, when it is when we are going to differentiate with respect to time, we are getting 0. So for this mathematical property, this must be the property which is to be satisfied for the steady flow. So what about pressure? Dou p by dou t at x naught, y naught, z naught should be 0. Dou rho by dou t, okay, density, right? Dou rho is nothing but density. X naught, y naught, z naught is equal to 0, where x naught, y naught, z naught is a fixed point in that fluid field. So why it is 0? Because it is same. Okay. So steady flow is that type of flow in which the fluid parameters like velocity, this condition must be satisfied to represent it as a fluid flow. That is velocity dou v by dou t in direction of x, y, z should be equal to 0. The pressure dou p by dou t should be equal to 0, and dou rho by dou t should be equal to 0. If this condition is satisfied, it is nothing but our steady flow. So what about unsteady flow now? This unsteady flow is that type of flow in which fluid parameters like velocity, pressure, density at a point changes with time. Okay, it will not, in the steady flow it will not change with time, but here unsteady flow it will changes with time. So mathematically how can we write dou v by dou t, the velocity is changing, it is not equal to 0. Okay, it is not equal to 0. So dou p by dou t is not equal to 0. When these are changing, the rho density will also change, because density is depending upon what, the velocity and also pressure. Fine. So the unsteady flow is that type of flow in which the fluid parameters at a point changes with time. Steady flow is that type of flow in which fluid parameters like velocity, pressure, density at a point do not change with time. Do not change with time, steady flow. Changes with time, unsteady flow. Fine. We'll see some of examples. So see, steady flow at distance y. What is the time? At a time t1, at a distance y, this is the flow. So at a time t2 also the flow is same. The distance of y is same. Okay, this is a fluid flow in one type. Okay, but at another cross section at a time t1, if we take at a time t1 the velocity is y1. Okay, and at a time t2 also the velocity is y1 only, the distance. Okay, if we calculate the y1 as the fluid parameter, then at a time t1 here it is y only, at a time t2 also the property is y only, like that you take. At a time t1 the, if it is y1, at a time t2 also it will be y1 only. Okay, t1 ಅಲ್ಲಿ y1 ಇದ್ದಾಗೂ t1 ಅಲ್ಲಿ y1 ಇರುತ್ತೆ, ಟೈಮ್ t2 ಬಂದಾಗೂ y1 ಇರುತ್ತೆ. ಡಿಫ್ರೆಂಟ್ ಕ್ರಾಸ್ ಸೆಕ್ಷನ್. ಒಂದು ಇನ್ನೊಂದು ಕ್ರಾಸ್ ಸೆಕ್ಷನ್ ಹತ್ರ ಬಂದಾಗ t1 ಇದ್ದಾಗ y ಇದ್ರೆ t2 ಇದ್ದಾಗೂ y ಇರುತ್ತೆ. ಅನ್ಸ್ಟಡಿ ಫ್ಲೋ t1 ಇದ್ದಾಗ y ಇರ್ಬೋದು. ಓಕೆ, ನೆಕ್ಸ್ಟ್ t2 ಇದ್ದಾಗ y, it is changing. Okay, this something mistake is done, but in unsteady flow what is happening? In unsteady flow, the velocity, pressure, density at a point changes with respect to time. Okay, here at a time t1 it is y, here t2 ಗೆ y ಇರಬಹುದು. Okay, here t3 ಗೆ y ಇರಬಹುದು, but it is changing. Okay, the flow which is changes with respect to time is called as unsteady flow and steady flow. So this is the water flowing in the canal, and the water flowing in different types of cross section we can see here. Okay, steady flow, we can give this as example. Okay, when this the flow is with speed. Okay, when the velocity of this speed is increases, when the dam is full, then you can see the unsteady flow here only. Okay, when the fluid is flowing speed, then the velocity at a particular time changes at a particular, it will change at a different point, different velocity will be there, like that. Steady flow, unsteady flow. Next we will go to the next slides, that is uniform and non-uniform flows. So what is this uniform flow? Uniform flow is defined as that type of flow in which the velocity at given time does not change with respect to space. Okay, steady unsteady idaga ನಾವು time reference ಇಟ್ಕೊತಿದ್ವಿ, here we have to take reference, that is space. Space ಅಂದ್ರೆ ಏನು? Length of direction of the flow, the length of direction of flow. So uniform flow is defined as that type of flow in which the velocity at any given time, the velocity at any given time does not change, it will not change with respect to space. Mathematically for uniform flow what we can write? Dou v by dou s. So dou v by dou t ಅಂತ ತಗೋತಿದ್ವಿ ಅಲ್ಲಿ ಸ್ಟಡಿಯಲ್ಲಿ, but here dou v by dou s at t is equal to constant time at any given time should be equal to 0 for uniform flow. So dou v is what? Change of velocity. Dou s is length of flow in the direction of s. What is a non-uniform flow? So non-uniform flow is that type of flow in which the velocity at given time changes with respect to space. So once the velocity, the flow of the type of flow in which the velocity it does not change with respect to space, then it's called uniform. If it changes with respect to space, then it is called as what? Non-uniform flow. How we can write mathematically? Dou v by dou s is not equal to 0. Not equal to 0 means it is not following the rule of uniformity, then it is non-uniform flow. D is equal to 0 means it is does not changes, means it is following the rule, so it is uniform. How we can write mathematically? Dou v by dou s is equal to 0, uniform flow. Dou v by dou s is not equal to 0, then it is non-uniform flow. Okay, keep these equations, mathematical equations are very important. Okay, if they can give this only, dou v by dou s, t is constant equal to 0, which type of flow? Answer like this in your objective types of question. Okay, so this was about uniform and non-uniform flow. So steady, see, steady uniform flow, this cross section you see. Okay, so discharge, q means discharge, it's constant, so steady uniform flow. Okay, the what is uniform flow? A different type of flow in which the velocity at any given time does not change with respect to space. So it will not change, the cross section is uniform, so there is no chance of changing. The length of direction of the flow will not change, but here see, the length of direction of flow changes because the cross section is changing. It is steady non-uniform flow. Okay, this is steady uniform flow, this is steady non-uniform flow. Okay, next, in three-dimensional flow we can see like this. So the x direction, y direction and z direction, the fluid particle will move like this also, like this also, like this also. This 3D image of this fluid particle for imagination is very difficult. Okay, just in the all the three directions it will change. Okay, for steady non-uniform flow. So next we will go to the next slides, that is we'll see some of the, okay, examples. Okay, see, river is there, this is the stone, right? This is the river bed. So this image is also taken from the internet. Okay, so whenever before reaching the stone, this is the flow direction, right? The flow is uniform, there is no any turbulency, nothing is there, it is calm, the water is calm, means the water, disturbances illa. Okay, it is uniform flow. Once the stone is objecting the flow of liquid, then what happens? Then the pressure depth is seen, it will fall, and it will fall and it will get reversed, the fluid particles will rebound here. So from this turbulence will be happened, and this we can see in the reverse, this we can see everywhere, right? In small sewer also we can see it. So here it is non-uniform flow. Why non-uniform flow? That it the velocity at any given time, the velocity of every particle here with the time changes with respect to space. Okay, if you take in space means here the space, the velocity dou v by dou s is changing. Okay, with respect to space, but here it is same, it will not change. Okay, the velocity at any given time does not change with respect to time, but here it is changing. So like this we can take that as example. Next, what we can see, same here, uniform flow is there here. Once it comes and it is objected here, then the non-uniform flow will happen. This is generally seen in every river, right? Fine, so uniform flow, non-uniform flow. Next we will see laminar and turbulent flow. Okay, so what is this laminar flow? So laminar flow is a flow, that type of flow in which the fluid particles move along well-defined path or streamline, and all the streamlines are straight and parallel. In other words, how we can say laminar flow is also called as a streamline or viscous flow. This type of flow occurs in smooth pipes having the low velocity of flow. It also occurs in liquids having viscosity. Okay, so this is also one statement, or we can tell as it is that type of flow in which the fluid particles move along a well defined path. Well defined path, or well defined path means what? It is a streamline. Okay, I am just defining the streamline. What is well defined path? Streamline only, no. It is also called as streamline or viscous flow. So this type of flow occurs in the pipes having the low velocity of flow. You can see in the image. It also occurs in liquids having high viscosity. Okay. See, the in this kitchen wash basin is there, no? So at a particular speed, so this you can see the laminar flow. So these are at every flow, if I take a line, it is called a streamline. Okay, the laminar flow we can give this as example. So a flow nodirala, a flow laminar flow ತರ ಇದೆ. So it is uniform, right? A well defined path ಅಲ್ಲಿ ನೀರು ಕೆಳಗಡೆ ಬೀಳ್ತಾ ಇದೆ, ಅಲ್ಲಿ ಬೇಸಿನ್ ಅಲ್ಲಿ ಬೀಳ್ತಾ ಇದೆ, ಕರೆಕ್ಟಾ? So that we can call it as a laminar flow. So for these three conditions are there, that is what fluid moves slowly. So here the fluid moves slowly only. Okay, viscosity is relatively high, flow channel is relatively small. So this is the flow channel which is relatively small. So what are other examples we can give? Blood flow through capillaries is laminar flow. In our human body system, the blood will flow, right? That blood is nothing but it is a laminar flow. Most type of fluid flow is turbulent. Turbulent means what? It is disturbing the type of flow. It will not have a defined, well defined path. Well defined path ಏನಾದರೂ ಇದ್ರೆ ಅದು streamline ಅಂತೀವಿ. So that streamline of flow type streamline ತರ ಇದ್ರೆ ಅದು nothing but this the laminar flow only. Okay, so we can also discuss it with a Reynolds number. Okay, Reynold, a scientist, he also gave a number. We'll see in the next slides. There is a poor transfer of heat energy. Okay, this is about laminar flow. Once you see the turbulent flow, you'll understand. So turbulent flow is what? Turbulent flow is defined as the flow in which each fluid particle does not have a definite path and the path of the individual particles cross each other. Okay, ಡೆಫಿನೆಟ್ ಪಾತ್ ಅಲ್ಲಿ ಇರಬೇಕು ಅಂದ್ರೆ ಲ್ಯಾಮಿನಾರ್ ಫ್ಲೋ. ಇಫ್ ಡೆಫಿನೆಟ್ ಪಾತ್ ಅಲ್ಲಿ ಇಲ್ಲ ಮತ್ತೆ ಇಟ್ ಈಸ್ ಇಂಟರಾಕ್ಟಿಂಗ್ ವಿತ್ ಎವ್ರಿ path means it is crossing, it is moving in zigzag fashion. In zigzag fashion, water when it moves in zigzag fashion, no, it is called as a turbulent flow. See, water coming from the shower or a faucet of the wash basin, it is laminar flow. So once it touches the basin, you can see the turbulent flow. Okay, it has no well defined path and the paths of individual particles cross each other. This is called as a turbulent flow. So in other words, it is the flow in which the fluid particles move in a zigzag path. Fine, this was about the turbulent flow. Next we'll see the Reynolds number. So why this Reynolds number, I'll tell you. So due to the movement of the fluid particles in zigzag way, the eddies formation takes place. What is this eddies formation? ಅದು ನೀರು ಬಂದಾಗ whenever ನೀರು we can take an example of water only. Okay, for this fluid, when the fluid flow will become turbulent, no, you can see the eddies formation means in the oceans we are seeing now that waves coming. So like that, similar to that waves only, eddies will be formed. Eddies means that julu julu we will see, no, in this whenever the water is becoming turbulent. So whenever you see in your kitchen, go and you just leave the water like this and the sound you can see, no, when it becomes turbulent. So that we can in turn, that's not perfect eddies, but you will get to know in the coming chapter. Fine, the about eddies. Okay, just you know. So the eddies formation takes place. So whenever the water moves, the fluid particles is moves in a zigzag way, the eddies formation will takes place, which are responsible for high energy loss. Here in the wash basin it is okay, but whenever we in the power plant, like whenever we are inducing power from the water, in that time these eddies, this water current will affect the turbines. It will give shock to the turbines so that it may be um, come to repair, means it is getting disturbed, the machine is getting disturbed like that. Okay, we'll come to know in next coming classes about eddies. Okay, so whenever the eddies formation takes place, no, heavy losses are happening, heavy energy loss is happening. So for that energy losses, Reynolds gave a number. Okay, what is that Reynolds formula? That is Vd by U. Okay, Vd by mu, this mu. So this is Reynolds formula. You just remember the Reynolds formula rho Vd by mu, or sometimes Vd by mu. So V is what? The density of the fluid. V is the mean velocity of the fluid. D is the diameter. Q is the volumetric flow rate. Okay. So mu is what? The dynamic viscosity of the fluid. V is the kinematic velocity of the fluid. A is the pipe cross sectional area. Okay. So what is Re? Re is equal to, we can take this also, Vd by nu. So where nu is what? Kinematic velocity of the fluid. So kinematic velocity, and this is rho by mu. Mu is the dynamic velocity, viscosity. So we have a relation between them. So just to remember this Re, Reynolds number. So he given a number so that ಅವನು ರೆನಾಲ್ಡ್ ಅನ್ನೋ ವ್ಯಕ್ತಿ ಸೈಂಟಿಸ್ಟ್ ಒಂದು ನಂಬರ್ ಕೊಟ್ಟಿದ್ದಾನೆ. ಸೊ ಆ ನಂಬರ್ ಏನಿದೆಯಲ್ಲ, ಆ ನಂಬರ್ಗಿಂತ ಕಡಿಮೆ ಇದ್ರೆ ಲ್ಯಾಮಿನಾರ್ ಫ್ಲೋ, ಆ ನಂಬರ್ಗಿಂತ ಜಾಸ್ತಿ ಇದ್ರೆ ಅದು ಟರ್ಬುಲೆಂಟ್ ಫ್ಲೋ. ಆ ಎರಡು ನಂಬರ್ ಮಧ್ಯ ಇದ್ರೆ, ಐ ವಿಲ್ ಟೆಲ್ ಯು ದ ನಂಬರ್. ವಾಟ್ ಇಸ್ ದಟ್ ನಂಬರ್? ಇಟ್ ಈಸ್ in the coming slides. If it is there, I will tell you, or I will write now. So if the range is between the two numbers, then it may be laminar or it may be turbulent. So to differentiate the laminar flow and turbulent flow, Reynolds gave a number, and the Reynolds formula is what? Vd by mu. So V is the velocity, D is the diameter of the pipe, where nu is the kinematic viscosity of the fluid. Okay. So what is that Reynolds number? So when a fluid is flowing in a pipe, the type of flow, okay, the type of flow is determined by a non-dimensional. So this Reynolds number does not have a dimension. It's called as a Reynolds number. When a fluid is flowing in a pipe, the type of flow, either it is laminar or it is turbulent, it is given by a non-dimensional number. It's called as a Reynolds number. Okay. He given a range of number by using this formula Vd by mu. Okay. I'll tell you. See, the Reynolds number correlates with the flow characteristics. See, Re is equal to mu V d by mu. Okay. When the Reynolds number is greater than 4000, it is turbulent. So see the water force. It is turbulent, unpredictable, and rapid mixing is there. So the water property is turbulent. What we want? When the Reynolds number is greater than 4000, it is turbulent. When the Reynolds number, okay, is less than 2300 is given. In the most of the textbook, it is taken as 2000. Okay. When the Reynolds number is less than 2000, it is laminar flow, predictable, it is slow mixing. When the Reynolds number is greater than 4000, it is turbulent, unpredictable, and rapid mixing. When the Reynolds number is in between this 2000 and also 4000, it is transitional, turbulent outbursts. Okay. It's a transitional flow. So laminar flow, next is turbulent flow. Next, if the number lies between 2000 and 4000, the flow may be transitional. Transitional means it may be turbulent, or it may be laminar, or it may be at a mixing stage, that it's in a stage where the laminar flow is changing to turbulent flow, like that. It's a gap when the Reynolds number is between 2000 to 4000. In some textbook it is given as 2300, and in some textbook it is followed as 2000 only. Okay. So this was about the Reynolds number. What the Reynolds number is giving us? The Reynolds number is a non-dimensional number which tells the type of flow which is moving in a flowing pipe, which is moving in a fluid flowing in a pipe. It will give the type of flow, either it is laminar, turbulent, or transitional. Laminar andre it is less than 2000, turbulent more than 4000. It is, if it is in between 2000 and 4000, it may be laminar or it may be transitional. It may be laminar or it may be turbulent, or it may be a transitional. Transitional andre no, it is just transiting, or it is just changing from laminar to turbulent. Okay. The value is like this. You have to remember these values, very important for your objective types of competitive types of exams. So this was about the laminar and turbulent flow. So next we will see the flow types. See the flow, laminar fluid Reynold. Okay, every flow fluid followed a straight path. Okay, that was parallel to the boundaries of the tube. See, if the laminar flow is there, low discharge, then the flow is like this. If it is transitional, it is just moving like this. The smooth curve is just to becoming, just to forming. Okay, when it is medium discharge. What about high discharge? Whenever it is become high discharge, the water flows as it wants. It is makes its own path. Okay, it will not hear anyone's, it will make its own path. So that type of flow is called as turbulent flow. Every fluid molecule followed very complex path that led to the mixing of the dye. Here dye is taken as an example. So what is transition flow? Every fluid molecule followed a wavy but parallel path that was not parallel to the boundaries of the tube. Okay. Okay, next laminar flow, it is just changing from this range to this range. Just what you have to remember: Reynolds number less than 2000 laminar, Reynolds number more than 4000 turbulent. If it is in between 2000 to 4000, it is transitional flow. So its image will be like this. So turbulent idre hinge, laminar idre ಈ ತರ, flow medium idre ಈ ತರ. Fine. This was about the laminar and turbulent flow. Next one is compressible and incompressible flow. So this compressible incompressible flow, it depends upon what? Density. So when a fluid is to be compressed, it depends upon the density, right? So the flow in which the density of fluid changes. The flow in which the density of fluid changes due to pressure and temperature variation from point to point during the flow is called as compressible flow. In other words, it is the flow in which the density of a fluid is not constant during the flow. That is, density is changing. Okay, if the density is changes, okay, from point to point during the flow is called as compressible flow. Okay, next, mathematically how can we write the compressible flow? See, density is not equal to constant means what? The flow in which the density of the fluid changes, the density is changing rapidly, it is not constant. The density is not equal to constant. If the mathematically this is proved, then the flow is still, then we can tell the flow is, the type of flow is what? Compressible flow. Okay, the sorry, the variation of fluid, the density of the fluid changes from point to point. Next, incompressible fluid. So the flow in which the density of fluid does not change. Okay, the density is same. Okay, the flow in which the density of the fluid does not change during the flow is called as incompressible flow. When the density will not change, how it can be compressed, right? You have to think like this. When the density is not changing, okay, it is not compressible only, it is incompressible flow. In other words, it is the flow in which the density of fluid is constant during the flow. So mathematically how we can tell? Rho is equal to constant. Whereas compressible flow, rho is not equal to constant. Because density is changing, it is compressible. Here density will not change. Whatever may you apply the forces, it does not change, so it is incompressible flow. Once it changes, it becomes compressible flow. This is all the difference between compressible and incompressible flow. So liquids are generally incompressible, means the density does not change, which means that the pressure and temperature changes have a very little effect on their volume, and gases are compressible fluids. So fluids means liquid also come, gases also come. So liquids are generally incompressible, whereas gases are compressible fluids. Okay, next, see the images. So here fluid is gas, here fluid is, this is gases are compressible. Here density changes. But what about liquid? Liquids are not compressible. So see the volume here. It was like this and it is like this. It is compressed. See the heights. But here heights are same. because it is not compressible. Liquids are not compressible, gases are compressible, so it is also called as compressible flow. Whenever a gas is flowing, whenever liquids are flowing, it is incompressible flow. Okay, next we'll go to the next slide, that is comparison between compressible fluid and incompressible fluid. So compressible fluid is a matter that can be compressed with the application of the external pressure. Fine. Incompressible fluid is a matter that cannot be compressed with the application of external pressure. This is definition only. Next, what is the difference can we give? Volume can be reduced in compressible fluid. The volume can be reduced with the application of the fluid pressure on the fluid. But here incompressible, volume cannot be reduced. Okay, when density is not changing, what about volume? It will also not change with application of the pressure on the fluid. Here, density can be changed with application of pressure on a fluid. They are just using here volume, here they are using density, can be changed. Here, density cannot be changed with the application of pressure on a fluid. So, value of Mach number should be greater than 0.3. Okay, it is one of the concept you will get to learn in your higher classes. Okay, so value of the Mach number should be greater than zero point 0.3 for compressible fluid, whereas in the incompressible fluid, value of Mach number should be less than zero point 0.3. The Mach number should be less than 0.3, it is incompressible. If it is greater than 0.3, it is compressible fluid. Fine. Next, your sixth type of flow is rotational and irrotational flow. So rotational flow is that type of flow in which fluid particles also rotate about their own axis while flowing along a streamline. Whenever a fluid particle will flow through a streamline, the fluid particle will also rotate about their own axis. So that type of flow is called as rotational flow. Okay. What is a rotational flow? It is that type of flow in which the fluid particles do not rotate. If it rotates, it is rotational flow. If it does not rotate about their own axis while flowing, it is called as irrotational flow. They are just direct questions. Rotational and irrotational flow. See, here the fluid particle is there. So rotational flow. This is example for rotational flow. Here it is irrotational flow. So P is the particle, P. Okay, PQ. So this particle, when it comes here, how is it? PQ. I'll tell you. Change the color. Okay, see, this is the particle PQ. So P is in the inside of the circle. Just to show you, okay, these are images. So P is inside and Q is this type. And what is the orientation? Orientation is like this. Okay, whenever it comes here, it rotated about its own axis. PQ is like this. Okay, the orientation is like this. So it is rotated now. When it comes here, it is again PQ, not this type, this mirror image of this. When it comes here, it's also mirror image of this. So it is rotating. The fluid particle is rotating about its own axis while flowing along a streamline. It is called rotational flow. Whereas it is irrotational flow, see, PQ, the location of the location of PQC, here also PQ, and the orientation is also same, here also same, here also same, here also same. Here it is irrotational flow. Okay, understood? Irrotational flow is that type of flow in which the fluid particle do not rotate about their own axis while flowing. It's called as irrotational flow and rotational flow. Next, see, fluid particles not rotating. Here we can see these are the fluid particle. So this is the irrotational flow, outer region flow. Okay, these smileys are smiling, looking at you only. Okay, but here these become naughty in rotational flow. So first fluid is seeing you, and here it is tilted. Here it is again tilted, again tilted, and again tilted. It is continuously rotating. So once the fluid particle is continuously rotating about its own axis, it's called as what? Rotational flow. Here you can see it is not rotating, it is irrotational flow. Now Ideal and real flow. So an ideal flow is the flow of a non-viscous fluid. In the ideal flow, no shear stress exists between the two adjacent layers or between the fluid layers and boundary. Only normal stresses can exist in the ideal flow. Fine. Ideal flow is a standard flow. We can imagine only, it does not exist. Okay. An ideal flow is that type of flow of a non-viscous fluid. In the ideal flow, no shear stress exists. Okay, between two adjacent layers or between the fluid layer and boundary, only normal stresses can exist in the ideal fluid. Whereas the flow of real fluid is called as a real flow, viscous fluid are called as a real flow. In the real flow, the shear stress exists between the two adjacent layers, and these stresses oppose the sliding of one layer over the other. Means what? The real fluids are nothing but the viscous fluids. So the stresses oppose the sliding of one layer over the other. See, if with a pipe, ideal flow like this. All the flow is straight, no restriction, nothing. All will come first in your class. Then it is ideal class. Without changing, without changing in marks, whatever you take. If you come all first rank, means if you are top of the college with same marks, if you find it the topmost mark, if all the students get 500 and they are in first position, then it is called as ideal class. But does it happen? It does not happen. Okay, we will study the subject on our interest, right? So some may get high marks and some may get low marks, and some may does not leave us to go front. So this is what called as a viscous. These forces oppose the sliding of one layer over the other. One student is not making other student to get more marks. He is not allowing them. Means what? He is just telling, why to read, come let's play, like that. Okay, he is also not studying and he is not allowing others also study, like that. Like that qualities it will be there, and it is called as a real fluid. Okay, if all of you get 500 marks, means it is an ideal. Okay, so the ideal fluid is a flow of a non-viscous fluid. In the ideal flow, no shear stress exists between the two adjacent layers, whereas in the real fluid, it's a viscous fluid, shear stress exists between the adjacent fluid layers. It is about the ideal and real fluids. The real fluid flows implies friction effects. Ideal flow is hypothetical. So ideal flow fluid is hypothetical, means it is imaginary, it does not exist. Okay, so real fluid implies friction and it assumes no friction. Fine. Next, so this is the same image. So ideal fluid ಏನಾಗುತ್ತೆ, friction 0, viscosity 0, energy loss is also 0. When it is real fluid, friction is there, real flow is also there. It is not equal to means 0, means it has some value. Energy loss is also there. There are students scoring good marks, there are students scoring less marks, and there are the students who are in between them. So like this was this was about your ideal and real fluid, and the other types of fluid we will take in our next class. So other type of fluid means 1, 2 and 3 dimensional flows, and other chapters, other topics will be covered in your next class. For this session it is enough. I hope you understood. Thank you.